Hello everybody. With this video we'd like to give you some advice on importing speaker measurements into the System Designer. With the System Designer you can create FIR crossovers with equalization of the speaker's amplitude and phase response. And to get good results out of this you need good speaker measurements. What means good speaker measurements? The measurement should contain only content of the loudspeakers, so only the speaker's impulse response and not any room reflections. The signal to noise ratio must be sufficient. You should not have any nonlinear distortions and not too much noise, of course, and the file must contain a valid frequency spectrum from 0 to half the sampling rate. Furthermore, the measurements should not be smoothed. The frequency spacing should be constant, so you should not export or not have any logarithmical spaced frequencies. I will explain some of these features while doing the import. So let's start. We have a new project here for the PPA 1002, so we have two outputs and we will import a woofer and a tweeter measurement now. So in output 1 I will import a woofer measurement by clicking new, add new measurement from file. So in this directory we have some measurements of a different file type. So you can see that we support some native formats of other measurement software, and if your measurement software is not supported, in most cases you can export text files. So we click on text files and I prepared some low frequency and high frequency content. I will import the woofer and you have a preview window here, and you can see that there are 3 columns of data and there's a header on top, and you can see that the columns are separated with white space. So now we click on open and then we see the import wizard, and we see that we have some parameters which we can adjust here. And we have some automatically detected parameters, a status line, we have some edit fields here for ignored header content, for the evaluated data, and a graphical representation of the evaluated data. So first of all, let's set the number of header lines to 1, and now we see the header line is displayed here, and we can see that the columns are frequency, the level in decibel, and the phase. So we set the column separator to white space. Now we see that we have 3 columns here in the evaluated data, but it's still set to real and imaginary part, and we saw that we have magnitude in decibel and phase. So now we see that we have a spectrum here displayed. The sampling rate is detected to be 48 kilohertz, and the number of lines is a power of 2 plus 1. Now we can have a look at the frequency distance. So we see here that the distance is 0.73, and if we look at the very bottom of the file we see it ranges until 24,000 Hertz, and the distance is the same at the highest frequency, so it is a constant spacing, which is important. Okay, so we can import the measurement now, and we see in output 1 that we have the woofer measurement here. There is an amplitude spectrum, there is a phase spectrum, and we have the group delay in the lower window. Now we will import the tweeter, same procedure. Just for demonstration purposes I changed the sampling rate of the measurement to 44.1 kilohertz, which is not a big problem since the frequency is detected, and the software will do a sample rate conversion afterwards. So now I'm going to import it, and you can see that we have 2 valid measurements, that the phase spectrum looks quite clean, and for example for the tweeter you see that we have a quite constant group delay here. This is important since the algorithm to create the FIR crossover will evaluate the group delay to align the 2 measurements at the crossover frequency. Just for demonstration I will import another measurement which is not that good, and you can see immediately what's wrong with it. So you see that the signal to noise ratio is not very good. You see it's very noisy here at only 40 decibel below this area where the tweeter is active, and the group delay is totally noisy here, and the algorithm will not get any good results out of this. So we will delete that again, clean up, remove the tweeter. And now we have two measurements and can start doing the preset. But this will be demonstrated in another video. So take care, bye bye.